Okay, so let's do this. As in the other example, you know, it's always good to show, I'll go through this one, but it's good to show your work. You know, I mean, you don't want to just guess by going to Desmos and trying out a bunch of graphs, I guess. You know, you really don't want to guess though. And I like people, again, to show their work so that I know what's, you know, how they're thinking about it. Okay. All right, so, right, as I said already, the vertex is -4, -1, -4, 1, okay? So that alone tells us a good deal about the graph, about the equation that is. Since HK is -4, -1, as we saw already, that tells us H is -4, K is 1, as in here, just like the other examples. So what we get then is y is a times x minus -4 squared plus 1, which is this. So a lot of the work is done. We're not quite done yet, though, right? Because as you can see, we don't know what A is. Now, I did say you have this point, but again, I also said the graph passes through many other points, like -6, 0. You know, you should be able to see from reading the graph that each box represents one unit. So in other words, if you're here, let's say, and you move to the right one step, x went up by 1. So this is -5. In other words, this would be -4, -3, -2, and so on. That's what I'm trying to say. So we know it passes through 0, -3. I actually used that, but I'm just saying we also know it passes through -6, 0, and -2, 0. But any of the points will work. I chose 0, -3. Well, since it passes through here, that tells us when x is 0, y must be -3. So when x is 0, y must be -3. Okay, so let's plug that in and see what happens. Like so. We have -3 is a times 0 plus 4 squared plus 1, which of course is the same as a times 4 squared plus 1, which is 16 times a plus 1. I mean, again, if you left it as a times 16, that's okay. It's just better to have the number on the left of the variable. Although a is, I guess, not really a variable, but I think you know what I mean now. We're trying to figure out what a is. Okay, that's good. Okay. But again, so to get a, we have -3 equals 16a plus 1. That's what's happening here. Then we want to solve for a. We get it all alone. So we subtract 1. -4 is 16a. Right? We subtract 1 to get -4 is 16a. We get also dividing by 16. Okay? Right? We get -4 over 16. Right? Equals 16a over 16. So we divide it by 16. Then we get a equals -1 over 4. You could leave it as -4 over 16. As I said just before, you don't have to reduce your fractions. That is, you don't have to write them in lowest terms. You could, but you don't have to. And we get a equals -1 over 4. So altogether, we get this, as you can see. But again, notice how I'm showing my work here, right? You know, you want to make sure you do that so that I know that you can solve the problem. that you didn't just go to Desmos and guess or something. You really don't want to guess. You know, guessing is not the best way to approach these. Okay. Are there any questions about this one? Okay. So I figured it'd be good to do a system of equations example. So we have this one. What I'm going to do is we're going to solve this by elimination. And again, that just means we want to multiply an equation or both by a number so that if we were to add the equations, one of the variables goes away. That's the whole point. And as you saw in the notes that I emailed, I'm also going to solve this another way using substitution. I mean, you could technically solve this by graphing, but again, since we're in the online environment and you have free software, Desmos, that does the graphing for you, I'll just focus on elimination and substitution. Good. Okay, so what do we do? Well, looking at the x's here, right? Looking at the x's here, right? Well, we have 2 here, we have a half here. Okay, well, adding those directly is not going to help, but, so if the coefficient of x here, instead of a half, was say, I don't know, -2, then if we were to add, the x's would go away. So if instead of 1/2 over here, we had -2, then if we added, the x would be gone, right? Well, how can we get -2 here? Let's multiply by -4. That's what I'm doing here. That's what I'm doing here. So we have -4, both sides, okay? We end up distributing. We get -4 times 1/2 x minus 4 times 2y is -4 times 9. You know, again, you have to multiply everything by -4. So we end up getting -2x minus 8y equals -36. So essentially, we changed the system algebraically to this one, but that's okay because they have the same set of solutions. In other words, let me say that again. We multiplied the first equation by -4, and now we have this system. Okay, that's good because now if we were to add the equations, the x's would be gone. And that's what happens here. We're adding them. The x's are gone. We have -8y minus 3y is -11y. And so we get -11y equals -22. And so we have -11y is -22. And as before, we isolate y, correct? We isolate y by dividing. We get y equals 2. We get y equals 2. But we're not done yet, though, right? We don't want just y. We want x. Well, how do we get x? Well, we know what y is. So we go back to the original equation, original system, replace y in one of these equations by 2, and we solve for x. I chose this equation here. And why did I do that? Mostly because of the 1/2. You know, I didn't want to have to work with fractions. Not that fractions are bad, but it's just easier, I think, to work with this one. You could work with the first equation if you want. But either way, you replace y by 2, right? And we get 2x minus 3 times 2 is 14. Like so. Now we have another equation to solve. So we have 2x minus 6 times y equals 14. Not 6 times y, excuse me, 6 I meant. I think I said 6y. So we have 2x minus 6 is 14. Again, I'm replacing y by 2. So we have this equation. So we solve this for x. You know, as before, we get x all alone. So I add 6 to both sides. I get 2x equals 20. Okay. Then I divide by 2, as you can see, right? Because we want x to be all alone. And so x equals 10. So the only solution here is 10, 2. It's only one solution. Good. Okay. Now, I was also going to go through how to solve it by substitution. I mean, you could see it here. Let me just go through that quickly. Basically, again, you want to get one variable in terms of the other. So what I did, the equation I chose was kind of random. You can use either equation. What I decided to do was, from the first one, I got x in terms of y. I know normally you would get y in terms of x, but you know, who says you can't get x in terms of y? You want to get one variable in terms of the other. So we have this equation. Well, I want to get x all alone. We're getting x in terms of y. So let's multiply, excuse me, we subtract 2y first. So x is all alone. We get 1 over 2 times x is 9 minus 2y. But I want x, so what do? I have to get the 1/2 out of there by multiplying, like so. Doing so, you have 2 times 1/2 times x is 2 times this. We distribute, and we get x is 18 minus 4y. We're running low on time, so let me just say this. The rest of the calculations, as you can see, are here. But basically, once you know what x is, you go to the other equation and replace x in terms of y, and then you get y. You know what? I'm going to have to stop here because we're low on time. What I'll probably do is go through this example again next time. Again, because I don't want to rush through it, because then that's not going to help any of us.